Hi guys, and welcome back to my C++ for game development series. And in this part we'll be taking a look at world space and local space. Now this is a fairly simple concept. However, you will be running into various places where you'll be dealing with relative positions or the local positions, and as well as absolute or world positions. We'll be having a basic understanding of that today, and we'll just be implementing our own version of calculating local and world space. And since we have already created the vector3 class in the previous video, we'll be making use of that. So first of all, what is world space? So world space basically refers to your parameters or your coordinates, that is your position, rotation, scale, so on, with respect to the world origin. So what I mean by that is, let's say this is our coordinate axis. Let's start with 2 dimensions. We can extend the concept to 3 dimensions as well. So you have your 2D Cartesian plane, and this is going to be your origin. Now if I were to take a point over here, let's say this point is 2 and 2. This point has a world position, I would say, or an absolute position of 2, 2. So let's assume this is in centimeters, so it's going to be 2 centimeters and 2 centimeters. Now, one thing to note is that this position is relative to the world origin. Now, whatever axes I have drawn, this is the x-axis of the world and this is the y-axis of the world. However, let's say we consider an imaginary coordinate system somewhere over here. Now this coordinate system could represent an object that is placed, or maybe this point is present within an existing actor, which I will explain what I mean by that. And let's say there is a coordinate system which exists over here. Now let's say we have a coordinate system like this. Let's say this is 0.1 and let's say this is for example 1. Now the world position of this point, so let's call this point P. So the world position of P will still remain 2, 2. However, the local space position, so the local position of the point P is going to be 1, 0.1. So this is going to be world and this is going to be local. So it's going to be 1 and 0.1. Alright. Now one thing to note here is sometimes you might have to convert between your world space as well as your local space. So for that, all you would need is the coordinates of the origin. Now in order to actually get the world origin, or rather the origin of the imaginary coordinate system which we did, this data would actually be available to us in a game engine. But in this case, I will tell you guys what it is going to be. So we can actually change this. So this is probably a poor example. So let's just take 1. So let's say we start our coordinate system at 1, 1 just for simplicity. It could be anything else. And let's say we still have our point at 2, 2. 1, 1. Now if you were to notice, the local space position is 1, 1 as you can see. However, the absolute space position or the world space position remains 2, 2. However, I want you guys to note how we are actually converting local space into world space and vice versa. Now, if you were to observe, the local space origin is over here at 1, 1. Now, this is more of a brain teaser, like you would figure this out on the spot. But anyways, basically you would just subtract the coordinates in order to get the local space from world space and vice versa. So now the coordinates of our imaginary axis, so this is where our origin is of the imaginary axis, is at 1, 1. And if you were to notice, the local space coordinates of this is 1, 1. So in order to get the world space coordinates, you would just go ahead and add the local space coordinates as well as the origin position of our imaginary coordinate system. Note that this origin position is in world space again. So you're basically saying in world space our origin is at 1 comma 1, and with respect to this point we are 1 unit ahead and 1 unit above. So this is basically what you mean. Now we can obviously get our local space coordinates right from this equation. So it's going to be W minus L. So this is going to, or rather W minus A. This is actually going to be our local space coordinates. So let's say you had your world space coordinates and you know the origin of the object. You can easily find out its local coordinates. So local to world and world to local. Now let's extend this concept in 3 dimensions. So I'll just take a simple example for this. There is no need to waste time on this concept. So I'll take the same coordinate system and I'll add a z-axis. So if this x, this y, this is going to be z. You can verify this by extending all the fingers of your left hand. So your middle finger is going to point to the x-axis. Your index finger is going to point towards the y-axis and your thumb towards the z. So basically extend out your index, middle as well as your thumb finger. So let's assume we have 1 and we have 2 over here. Now let's assume that we have something, an object over here, and an object need not have one entity. Let's say it has a sphere and a cube. So let's draw our imaginary coordinate system. So we need to project it up. So it's going to be somewhere over here. So this is our imaginary coordinate system. And let's say over here we have a sphere as well as we have a cube over here. And this is the center of the cube. Let's assume that the pivot of the cube is at the corner, just so that our calculations are simple. And let's assume this is 1 in local space and this is going to be 0. This is corresponding to 1. This is just error in my drawing. And let's assume that this is also corresponding to 1. Let's say this is 0.5. And in this dimension we can draw the cube. And our cube is going to be something like this, and our sphere, obviously it's going to look like this, but it's in 3 dimensions. Now let's assume that this point is over here, and the z coordinate of this point, let's assume, is going to be 1. Now easily we can use the same equation to actually find out the coordinates of each of these entities in local space as well as world space. Let's do that. Now the origin of the sphere is same as the origin of our imaginary coordinate axis. So the world space of this coordinate axis is going to be the world space position of the sphere. So it's going to be, or we called it A in the previous one, so let's keep the same notation. And the local space coordinate of the sphere is going to be 0. 0, 0, 0. Now over here A is going to be 1, 1, and this one is 1 again. So it's going to be 1, 1 and 1. Now let's talk about the cube. Now we are obviously referring to this as the pivot point. So whatever coordinates we refer to with respect to the cube is going to be with respect to this point, obviously. Now in order to calculate that, we know the coordinates of the cube in local space. So we can deduce the equation from here. So in local space, the coordinates are 0.5 and 1. So local space cube is 0.5 and 1. And for world space, you can just do local space plus the coordinate system's coordinates. So world space cube coordinates will be equal to 1.5 comma 1.5. Or rather 2, I guess. 2. And we forgot the third dimension for this cube over here. So this is 1 and this is 1 as well. So we forgot that dimension. Now this is going to be 2 and this is going to be 2. And if we were to notice, this coordinate axis is 1 unit outward. So it's corresponding to this. And the cube is 1 unit relative to your local coordinate system as well. So it's going to be 2 units with respect to the world coordinates. Now don't mind, it's not accurate since we are trying to represent 3 dimensions in 2 dimensions. It is not going to come accurately. And as you can see, we can use the same equations which we did for 2 dimensions to find out the world space and local space coordinates if we know this value of A. Now, how do you actually get the value of A programmatically? Basically, there's a function in Unreal. I'm talking about this concept in context of Unreal Engine, of course. So, in Unreal Engine, whatever get actor location, the function which you're probably familiar with if you worked with Unreal, that one is going to get us the value of A. So that is going to be the origin of the actor. Let's say the actor has a sphere and a cube like this. We can find out the coordinates like this. Unreal, of course, has its own functions. We are just doing it for the concept understanding. So that's about it, guys. So this is how you would find the world space and local space coordinates. All it basically is the position with respect to the world origin and with respect to the particular actor's origin, or we can say in this frame of reference. So that's about it. Let's head into C++. Alright, so now we are in C++. Now let's go ahead and try to just have a basic implementation of what we just understood. To be completely frank, we don't really require an implementation for this. This is fairly simple. But anyways, for those of you curious, I'll just show you guys a very basic implementation. However, note that you will be using built-in functions for all of these things. So let's go ahead and create 2 new classes. So new item, class, and I'll call this one actor. So this is going to represent an actor, basically any object that's placed in the level. And I will create something known as a component. If you notice, I am using the same convention as used in Unreal. So another class, and this one will be component. Basically, actors will contain components, and these are the actual functional elements of an actor. An actor basically just encapsulates it so that you have one entity to deal with, and within an actor you'll have multiple components. So I'll go ahead and head into actor, and these are the members that I'll be having. I'll just make them public for now, but you need not. So let's go ahead and create a vector of components. So I'm going to include vector here, hash include vector, and what we can do is we can create a vector of components and call this one components. Obviously we will need to include our component.h, hash include component.h. Now what we can go ahead and do over here is also store the location. So let's just call vector3 location, and we can go ahead and include our vector3 over here, vector3.h, and this should be totally fine. Now once we're done with that, we can have other methods later. Now what we can do is we can go ahead and go to our component class over here, and over here we can also just store the parent actor's reference. So let's go ahead and actually have that as well. And over here too, I prefer having component pointers since we shall be dynamically allocating the memory, as well as we don't want to make any copies of components, so you generally use pointers over there. Now go ahead and include actor. This will result in a circular dependency most likely. Oops. Actor.h, and if I were to just go ahead and build this, now this is because of a circular dependency that we have over here. Now you require component over here, but again component requires actor. So what you can do is you can forward declare this once again. So you can go ahead and forward declare actor, and this should work. Now what we can do is we can go ahead and have an actor pointer and call this one parent. This is going to work totally fine. We can go ahead and build this, and as you can see, the build succeeds. So this is going to be parent. Now what we can do is we can also have a location over here. So vector3 location. Alright. Now if you were to go ahead and see this variable here, this will be our local space coordinates of our actor or of our component basically. So in order to get the actual world space location, we need to add that with our parents location. So what we can do is we can create a function. So this one is going to be vector3 location, or rather get world location. And this one is going to be const, since we aren't going to modify anything. Now a simple implementation for this, we can just have it, or we could have done it in line as well. So we can go ahead, and here we are going to include vector. So it's going to be vector3, the one which we created. Now this is going to be parent. So parent is again something which we need to define. So we can go ahead and include actor.h. So parent location plus we can go ahead and add our own location. Now if you were to notice, we get this error over here. That's because we haven't defined the plus operator. We can go ahead and define minus and plus, something like this. I've already done minus. We can go ahead and do that for plus as well. So if I were to go ahead and copy this over, so operator plus, you can just copy this over. This is fairly simple. So it's going to be plus over here, and it's going to be plus over here. So this is the same thing what we did with the division operator. So we can go ahead and do that, and we should be getting our world location as expected. And if we head into our component.h and we go ahead and check this out, this should be working fine, and we should make this public if we want to access the function outside. And if we head back into our actor class, we can go ahead and get the location which is there over here. And if we want to get the local space location, it's going to be inside our component itself. And for the world location, we already have the function. So we can go ahead and test it out. So let's go ahead and create an actor. So hash include, this one is going to be actor.h. So let's delete all of this. We do need a few parameterized constructors if we want to initialize it correctly, but I'll just do a quick demonstration here. So let's call this one a1 equals new actor. I suggest you use smart pointers. However, this is just a quick demonstration. So I'm going to just create a new actor, and at the end just make sure I'm deleting the actor. Alright, so now what we can do is we can go ahead and set the location to something. So it's going to be vector3. Let's say 2, 3, 4. So this is going to be the world location of the actor, and we can go ahead and add a component as well. A1 components dot pushback. We can go ahead and add a new component, and this should work. Now that we have our new component, what we can do is we can just grab the first component that we have, and what we can do is we can go ahead and set the location. So this location is going to be, say, vector3 1 1 1. Now we can go ahead and print it out. So we can go ahead and say actor location, and we can go ahead and print out A1's location. I think toString was the function that we had. we can go ahead and print the local coordinates of our component as well as the word coordinates of component. Local location. So this will be for the component. For component, this is the component that we have. It could be anything, maybe some sort of a cube, sphere, or any other model that you have. So it's going to be A1 components of 0 dot location. So this is the one which we are looking for, and this is going to be word location for the component. Alright, so this is going to be A1 components, and we are going to get the word location, and we are going to convert that to a string. So over here we can just go ahead and include vector. So hash include our vector, not the STL vector, I mean our vector3 class. And now technically it should be building totally fine. So one thing that we did forget to do is actually set the parent over here. So we had to do that over here when we created the actor itself. So we can do that in the main for now. So we can get component 0 and set the parent to be equal to A1. We can go ahead and run a debugger, and as you can see we get the location 234, the local location as well as the word location of the component. So this was just a simple concept which I wanted to tell you guys. I don't think there's too much more to cover, and I feel like with the foundation of C++ you would be able to get into creating games itself. So that's it for this video guys. Thanks for watching. I hope you guys enjoyed the video and this series, and I'll see you guys next time. Goodbye.